Hello and welcome back to Tech Days Online. I'm Andrew Fryer and I know nothing about Spark. I know nothing about R. And in the way that we've changed many things at Microsoft, we've also changed the way that we do the Microsoft Valued Professional Program, where we now encourage people to get involved when they are playing with technologies that weren't originally invented at Microsoft. And that's what we're about to cover. And we haven't just got an MVP here. We've got a regional director who's a sort of super MVP. So I'd like to introduce you to my good friend, Richard Conway.
Thanks, Andrew. And thanks for having me back. It's nice to be here for the second time in just as many months. So,
yeah.
Well,
you did a good job last time.
Thank you. Thank you. So as you said, today we're going to be talking about Spark and R, and specifically on HD Insight and how we can use the platform service HD Insight in Azure to take, and this is one of the things that we found with customers recently. There's so much IP that customers have developed in R, but you run this on a single machine, on a single laptop, and obviously it's got scale challenges.
Yeah. Well, R's got scale challenges because it traditionally runs in memory, doesn't it?
Correct. Yeah.
And big data is petabyte scale, and memory is gigabyte scale.
So I mean, this is one of the things that Microsoft have done is they've enabled this so that you can scale R, and we're going to be discussing some of the technologies. Spark is one aspect of it, R Server is another aspect of it, and we're going to see how they're put together now so that you can distribute R in the most incredible way.
Great, let's get going.
Okay, so I'm going to give you a little bit about me, a little bit of background. So I'm obviously, as you said, I'm an Azure MVP and a regional director, and these are great prestigious honours for me to have these titles from Microsoft. In my professional career, I run a data analytics consultancy called Cloud, and we're doing some great work across the board at the moment. We're gold partners, so we have cloud platform and data analytics competencies, but last year, in recognition of all of the contributions that we'd made, we won the OSS Partner of the Year. Right. And this was primarily for a lot of the contributions we've made to Spark and Storm and Apache libcloud and all the various Apache tool sets. We've helped Azurify them quite a bit. So
yeah, because I think sometimes when people think open source, they imagine sort of websites and mobile dev, but really, for me and you, it's all about what we can do with big data.
Yeah, absolutely. So I think we've had a great time actually contributing to some of these projects. Yeah. I think we call ourselves serial user group creators. We have 3 now, and they're all great fun. They're all very different, but we obviously founded the UK Azure user group, and we run another group called the IoT Innovators, which is doing really well, which thank you very much for your help with key event. Got some good photos of you.
There again, open source, Raspberry Pi, Raspbian,
absolutely.
Talking to Azure for sure, but
that's right. We had 50% of the audience using Linux, noobs, which was great at the last event, and we've got a new user group which we've just founded called the UK Cloud Infrastructure User Group, which is a synthesis of DevOps and infrastructure. So different kind of audience from our traditional developer audience user group. This year, hopefully, we'll be running AzureCraft again. But we're also going to be running another conference called Cloud Brew, which, as you guessed it, is taking place in a brewery in Faversham. So I'll make sure you get a VIP invite.
Very, very kind of you. As long as I've got someone to sleep afterwards. Right.
Fair enough. And lastly, I just wanted to say that we were users of Spark since 0.4. And it's now in version 2.0. It's a fantastic product. We're going to hear about it today. Yeah. And we've done a lot of things to contribute to Spark. So we wrote early Event Hub receivers. We've written a receiver, as you'll see, so that we can stream messages from the service bus, just to help people who are using different aspects of Azure.
So it's not just the consulting you do, it's actually contributing back by GitHub and actually into the product.
That's right. Everything, we have that mindset. Everything that we do, we try and think of an open source angle.
Fantastic. Right, so imagine some of the people watching this are traditional Microsoft events, fans if you like, and they won't know really what Spark is at all. And then we're going to have some Spark people who want to know how it works on Azure. So we need to probably cover both of those.
Exactly, right. So we've got a lot of material to go through today. So what I'm going to try and do is just give you a list of some of the things that I'm going to run through today. So first of all, we're going to be talking about data at scale, and we're going to be talking about what it means to shift from this mindset of running R in your R Studio or now Visual Studio, and I'm going to show you a demo of that. And we're going to talk about some of the fundamentals of Spark, and Spark is a very memory-bound framework. So, you know, we can do very, very fast big data calculations because we drive these calculations across large swathes of memory across a cluster.
Yeah.
So this fits in well with the Hadoop model, but we're not bounded by disk, unlike Hadoop.
Yeah. Okay.
We're going to be talking about data frames, which for many data scientists who've been using R and Python for many years is just the standard currency for data.
Yeah.
We're going to be talking about how Spark has integrated that. We're going to be talking about Spark and machine learning, Spark streaming, and we're going to tie this all together by talking about R server and how that works with Spark. What I'm going to run through is I'm just going to talk about this transitioning data science at scale. So, you know, with R, we'll ingest data, we'll manipulate data, and we'll make predictions on it. Okay, R is a very statistical language. It's had a statistical inheritance. It was created in the late 70s in New Zealand University. It derived from a language called S, and you've got thousands of people that contribute to CRAN, which is an open source package.
I even saw a package on there the other day, all the different Crayola colours for crayons.
I can well believe it. I can well believe it. It's
bizarre. Maybe not one you're going to use, yes, but we all use, I don't know, ggplot or and then in the Python, it was a bit like the Python where you have scikit, but here we're using the forecasting modules, and like if you want to do a REMA, you know, somebody's written that
for time series. Yeah. So and that's the whole point, that you don't have to reinvent the wheel. So Microsoft making this huge strategic investment to actually distribute this is very, very meaningful. You know, because this means that people can take code that they've literally written for almost 30 years now and use this in an environment at scale.
Yeah.
And not be bound by the operations or the management or the cluster, because Microsoft's taking care of that for you.
Yeah,
so R looks a little bit like this. We can see we'll read and fire, we'll turn that into a data frame. LM is a linear regression function which we can use in R, and that will give us a summary. What I'm going to do quickly is I'm going to show you, because I wanted to make these things. Oh, who's that? Oh, who's that?
Who's that guy?
Well, whilst this is on the screen, this is a snapshot, a photo from the last event that you were Andrew helping out, and teaching everybody Raspberry Pi on Linux and WinIoT Core. Very, very successful, well-attended event. But these are the sorts of things we do with the community, as you know. Okay. So anybody that wants to find us at the UK Azure User Group, go to meetup.com, IoT Innovators UK. We're on Meetup. We're running things all the time. This month of October coming up, we've got a couple of talks around serverless computing, so Azure Functions, the Web Apps team, that sort of thing. So it's going to be great stuff. Okay, so I am going to just show you a quick demo. So this is R in Visual Studio.
Right, and not many people will know that that's in there.
Oh yeah, so Microsoft have OpenR now, and we can create an R project. Just to quick start this, I'm going to be consistent with this with all of the demos that I do. We have a data set, an Iris multi-class data set. It's a very famous data set dating back to the 30s, where iris flowers were classified based on their petal width, petal length, their sepal width and sepal length, to try to determine which class of 3 iris flowers they were. So we'll be manipulating this because it's a very standard data science data set.
Yeah. So some people may be familiar with AdventureWorks and SQL Server. It's just a well-known data set, and this is the equivalent in a data science world.
That's right.
Yeah. Okay.
That's right. So what we'll find, and we find this with languages like F#, we have the ability in Visual Studio to just highlight this and
run that bit of it.
And run that bit of code. And you can see here on we've got our R interactive here, and it's actually run this code. But there's also a plot, so we've done a linear regression based on sepal width and petal length for the classes.
Where did that go?
Well, we haven't done the plot yet, but let's run this plot now. So And you can see we've got all of the data points
Yeah.
for the different types of classes, and
Yeah.
you can see that some of them are in triangles, some of them are crosses, some of them are circles.
Yeah.
But we've got that regression line from these two
Yeah.
variables in between, so it's found the line of best fit there.
Yeah.
And we can do this again, and we can call our summary.
And that's just like a line of code, and you've kind of, I mean, that would be like lines of code in any other language. First of
Yeah.
all, just to doing the plotting is one thing, but to be able to actually put a best fit line through that.
But
Yeah.
just like that, in a few
Yeah.
lines of code, and you can see that we've got summary statistics,
Mhm.
so we
Yep.
can see what our fit is using this R² value.
Yep.
It's not great. We've got about we've got some errors in there that
Yes.
we've introduced, distances from our line of best fit, but it's okay.
Hmm.
But the point that I wanted to make is that all the strategic investments that Microsoft are making in R, they're actually pushing down to the clients now. So Visual Studio is now being used by a lot of R developers instead of things like RStudio, which have been
Yeah.
very common up until now.
Well, you're going to get a source control experience here, and also we're really about not making sure that data science just sits inside a small team or just the guy sitting in a basement. This project is going to be part of a bigger project.
Yeah, absolutely.
And so we might want to persist this in the website. So we've got the website, we've got the R code, and we have a session today on Data Factory. So that's going to be in there to show where we got the data from. We've got everything under control.
Right,
And I
exactly.
think that multidisciplinary team, but everybody knows where everything is.
Yeah, so
Great stuff.
So I think what we'll do is now that we've looked at that,
Yep.
let's focus a little bit on Spark, and we'll talk about this basic concept of Spark, what it is, why data scientists love Spark so much. So essentially, Spark is a way to distribute a piece of software, a piece of big data software. I would generally write this in either Java, Scala, or Python, but now the underlying Apache Spark team have made something called Spark R, and Spark R allows you to run software from Spark software, but in the R programming language. So independent of our server, which we're going to look at, you can actually run code in R now, which is great. So what it does is it has, in the very traditional sense of Hadoop, it has a master, and it has a set of slaves or worker machines, and we can push tasks to these, and then that way, if we're reading information from Azure Storage or another file system like Data Lake Storage, then essentially what will happen is parts of each file will be read by some of the data nodes, which is how we can parallelize this activity.
Yeah, so sharding and this sort of stuff across these different...
That's right.
Yeah. Okay.
Where Spark is becoming incredibly powerful is that Microsoft have built a gateway that allows you to use an API, a Cloudera API called Livey, and they've integrated this into HD Insight so that I can send REST commands to submit my Spark software.
Right.
So what it means is it's a great way for me to write a piece of Spark software, whether it's an R, Python, or Scala, or Java, and then I can just remotely execute this software. So I can make it part of a workflow orchestration.
Yeah.
In the same way as you heard with Azure Data Factory, that underlying boundary is really a REST-based boundary.
Yep.
So it looks something like this, as you can see in the screen. Now, the fundamental unit of storage for Spark is an RDD, a resilient distributed data set.
Yep.
And that's basically an in-memory representation of your data stored twice, so in two different places in a cluster.
Right.
Okay, so let's say I have 5 data nodes in my Spark cluster, and I have a single master. 2 of those data nodes will store copies of my data set within that RDD. If one of the nodes, if there's a physical failure of one, it will copy the primary onto another one, or the secondary will become the primary, and it will copy it onto another one, so you'll always have 2 copies. Now you can see the fluency with the syntax here with these RDDs. Because they're in memory, all the operations on them are very, very quick, because we've got no I/O bottlenecks. So you can see that this is Scala code, and you can see that we start off with a variable called SC, which is a Spark context, and we load in a text file, which will allow us to load that text file from storage, and then we can apply a filter. So this is a very common example which sort of says, if it starts with error, an error in this case, you can well imagine it's a log file. Exactly.
Probably.
So then we'll remap this, and that remapping, you can see underscore is the variable that we carry across. So that's going to be our line in the log file, and we'll just split that by a tab, and then we'll take the second item. Okay. So you can see in one line of code we've actually filtered out all the data that we're interested in using.
And this is a sort of classic map reduce, but applied now into a memory technology.
Exactly. So it's very quick for that reason. And it also, one of the things that you'll find with Spark is that it's very easy to join data sets because of this. In Hadoop, it's much more complicated. It's not complicated programmatically, but in terms of the complexity and the amount of time that that gets added on to these operations, it's not really meant for multiple joins of data sets in this way. Okay. So what I'm going to do, a picture is worth 1,000 words, as you know. So I'm going to walk through these and these demos. So I've created a Spark cluster and an R server cluster, and we'll see that this runs on HD Insight, and you can see that we've got a number of different things available to us here. We've got we can scale our cluster, so if I want more nodes, I can scale that. We've got something called applications and script actions, which allow us to actually, because this is built on a subsystem called Yarn, it allows us to install other things that can run and consume Yarn. We have a set of dashboards here, which is what we'll use mainly, and you can see that we've got dashboards for HD Insight, for Yarn, for all of the different history server for things that we've run. But data scientists love this thing called Jupyter Notebooks.
Oh yes, I know.
As you probably know. So what I've done is I've uploaded a few Jupyter Notebooks scripts, and we're going to start with the RDD and data frames basic one here. And what you can see is that I'm sticking with the Iris multi-class file, and I've got each of these running in one cell. Now, it takes a bit of time with Jupyter Notebooks to create something called a Spark context. Because that initial execution, loading all these things into the environment, takes a while. But I'm gonna try this. So we just press play, and you can see that the circle's gone from a hollow circle to a filled circle. And that means that this web page is talking back to my Spark cluster through the gateway.
I'm not having to refresh or anything, it's just working away there for me.
Absolutely. So, and you can see that we've already got some feedback. So it says creating Spark context as SC. So that Spark context is fundamental to everything that we do in Spark. In 2.0, the naming convention has changed. We've now got a Spark session. So there have been some major innovations in 2.0, and they haven't, as yet, we're still waiting for 2.0 in HD Insight, but it should be there soon. So I'm running on a Spark 1.61 cluster, which is one of the last releases. But you can see here, so it might take a minute or so, but it's going to be reading in the contents of the file, and it will give me a count of the lines.
Because obviously I suppose that before we start doing this data is somewhere, and it's got to be like physically loaded into memory, and it's the latency on the other end, not the memory itself.
Exactly. So what you tend to find is that there's a lot that goes into Spark. As we'll see, there's a, here we go, it's pretty much returned now. And you can see that there's a couple of links. So we get a link to the Spark UI, we get a link to the log, so I can test all the errors and the outputs and things like that. You can see here we've got something saying creating Hive context to SQL context. That's actually pretty important because Spark also allows you to interrogate a Hive warehouse. So if you've a lot of companies have got Hive warehouses which literally span petabytes, and they don't want to go rewriting stuff when they've spent years building up these Hive warehouses. So in this case, the SQL context that I've got out of the box here allows us to do Hive queries using HiveQL, which is great.
Okay.
So you can see I've got 150 lines in the file, and it's come back with 150. Okay, so I'm gonna run this second line, and you
so
can
just
see
highlighting a row, hit and run here for people who haven't seen Jupyter Notebooks.
exactly. So then you can see here we've got these values: the sepal, petal, width, and length, and we've also got the class, which in this case is Iris Setosa. So I've just taken the first line of that file. Everything is read string by string. Now you can see that they're comma separated, so I want to split them. So I can apply a string split over the comma. And here you mentioned map reduce, so this is a map reduce function. In one line, what I'm doing is I'm saying, you know what, let's take the class of each flower, and I want to count. Every time I come across this class, I'm going to emit a 1. And then I'm going to count all of those ones. So you can see here that when we execute this, we should end up with
just counts the different classes.
That's right. Okay. So now that's a function, and you can see it's an RDD of type string and int. So we've got the string here, we've got the int here, and I'm going to take the top 3 because I know that I've got three flowers. Okay. So, and there we go. So we end up with an array, and we can see Iris versicolor 50 of those, Virginica 50, and Iris setosa 50. 3 different flowers, 50 lines of each. Right. So that's a very traditional way to write Spark software, to use that link style syntax to do map reduce. But it's not the only way, and it might not even be the best way now. So what I'm doing here is I'm importing a SQL context this time. And I'm creating, in Scala, I'm using a case class to create an Iris class. And then I'm doing the same map, but this time I'm mapping all that data to the Iris class that I've created, because I know all the attributes of the class, the different widths and lengths of the flower, and the species of the class. And then I'm using this 2df function.
Right, to data frame.
Exactly.
And
then that gives you parity in Spark with all of the things that people have had in R and Python for years. So I can then manipulate, I can pivot, I can do group bys, I can do all these wonderful things, and it doesn't take me a lot of energy or
And
code.
you could do that plot that we just saw just now, for example.
Exactly.
Yeah, great.
So, which we'll see shortly.
Oh, right. sorry, I'm stealing up.
No, not at all.
It does show I'm paying attention.
Okay, so now that we have our data frame, we can just, one of the things that we had in the class was species.
Yes.
So I can group by species, and then I can count, you can see, and then I can show the result of that. So if I just hit that, Spark should come back with a table that just breaks this down by the species. So you can see, again, we can use a data frame to do very continuous, and there's our result, very continuous syntax here. And that's not the only way that we can approach this. What we can also do is we can use SQL. So Spark has a SQL language, an ANSI SQL language called Spark SQL. And if we register a table, in this case called Iris, then I can say select species, count species, from Iris, group by species. And that will give me the same as that link query on the data
which will be much more familiar to perhaps many of our audience.
And that's the transition. In the last 18 months or so, since Spark SQL has become prolific, you'll see that many people have been doing these kinds of queries.
And even our business users are going to be more familiar with that context. They may be working in Excel and they're familiar with queries. So I think it's about that democratization for me as well, and breaking these barriers down between different disciplines.
Yeah, completely agree with you. So we can run similar things in Python here. In fact, we can use, through Jupyter Notebooks, we can effectively run any code in any language. It has these things called magic. So if we prefix them by %%, we can run code in R in here. It will find the R interpreter. So what I'm going to do is I'm just going to show you another way of doing this. So Microsoft have got very good capability, so we automatically get all this beautiful DNS to our SSH service. So what I'm going to do here is
so you're connecting, if I've got this right, to the head node of the cluster.
That's right. Yeah.
So it's like the brain of the thing.
Yeah. Exactly that. Right. So I can just copy this, and what I've done is, here we go. So we're going to start an SSH session, and I've just got used to using Bash now. I tell you,
well, it's on Windows 10 now, so I may have to get used to it too.
It's taken a while, but got to say I'm loving it. So we enter the password, or if I'd set this up with a certificate,
you'd post your certificate to it, and then it would know who you are.
Yeah. So now we're on the Spark cluster, and one of the things that we can do is we can run this thing called a Spark shell. So Spark shell is the Scala version of this shell. Natively, Spark is written in Scala, but there's a shell that I can use in Python called PySpark, where I can issue Python commands. But what I'm going to do, just for simplicity, I've written something, and if I can find it, is it here? Yes. So I wanted to just show you a very traditional word count.
Yes.
Okay. So you can see what this actually does is it submits Spark Shell as an application to Yarn, the underlying subsystem. And Yarn will have to accept or reject that because Yarn will work out whether it has enough resources.
Yeah. Yes, so there's a whole sort of orchestration thing going on behind the scenes when you run a query. It's a bit like compiling and then running rather than just firing it.
That's right. So, for example, in this case, if I had too many Jupyter sessions running, Jupyter Notebook sessions, I might get errors when I try and run this.
Okay.
Okay, so let's just see this through. So now you can see why Jupyter Notebooks takes a while to actually start up, because there's a lot of things that Spark has to enable to be able to run software.
But this is all sort of one-time work in a context, isn't it, that we're working. Once we've got this, it's all going to be super speedy. We're getting that power of the cluster coming there.
That's exactly it. And most people run. Okay, so this is something that I deployed to the cluster, the history of the US, and you can see that I've read that in, but I've also run a map reduce. So I've used these flat maps, and we'll look at the output in a sec here. But I will do that just after I just show you the code, if you can see that on the screen. So we read in the history of the US from Gutenberg. I run a command called flatmap, which will split every single word out. So a traditional word count, and then you can see here that I emit the key value pair, a tuple. So I emit the word and I emit 1 every time I see that word. Then I run the reduce operation. What I do is I then pivot so that I can sort this, and I can sort this by the highest and the lowest frequency of those words.
And that kind of operation can be compute intensive. Well, it's going to maybe back down to one module, because you've done the initial work on the word counts across your cluster, but to put them in order, a sort, you've typically got to kind of do that in just one place.
That's right. That's right. So in this case, if I run that. So let's do something like this. We'll take the top 5, and it runs that across cluster, so you can see that it's not precise. It's picked up the word the and of and an and to, which we would expect.
The stop words is there.
But it's also picked up blank spaces that our algorithms picked up. So it's not 100% accurate, but you can see that in very, very powerfully we've read an entire book in, and like in a few seconds.
Well, we've got the thing, we're ready to play now. So we might have another data set with stop words in. We could filter out and see what the proper words, or bigram analysis, or any of the other things that a linguistics expert would then start to do to understand, maybe write an abstract of this.
Yeah, exactly. So I mean, so it's all good, and so to leave that. We can just exit this, and you can see it does a clean shutdown there, and I can then exit this shell session, and we'll just leave that up and running. So moving on a bit, I just want to discuss a little bit around machine learning and Spark. So so we have data scientists frequently use the term vectors. So, you know, a vector might be a set of features that they've got within a data structure.
So one-dimensional array is perhaps another way.
Exactly.
Yeah.
So, and you know, they're common to all of these different frameworks. Spark actually calls this a vector. So that's a primitive. So that's our representation for a set of features, and we can have them as dense or sparse. You know, so we can have almost like arrays within arrays, or we can have something that are variable in size, or we can have, just like you say, that one-dimensional array that has just got items in it. And then Spark has the concept of this thing called label points, and they encapsulate a vector, but they also encapsulate a label. So vectors, features in very much in our data science, machine learning speak, label point encapsulates that label as well.
Right, okay.
So what we're trying to predict.
Yep.
And we can transform everything into vectors through map functions. So there's some very common patterns in using Spark and machine learning. I just wanted to show you this one thing, and we hopefully I got pain au chocolat worded
one
correctly.
No, I think that's okay.
So this is going to be relevant because I've got a I'm going to show a classification example later on with our server if we have time, and effectively, if we were trying to predict based on characteristics of pastry whether something was a donut, custard cream or pain au chocolat, then we would end up with our actual and predicted like this.
Yes.
This is it's effectively called a confusion matrix.
Yes, for a three-class problem.
That's right. So so we can see that if we take one class like a custard cream, we have these different things. So for the custard cream, you can see that out of 30 or so, we got 12 of these right. Well, 12 were custard creams, although
we predicted that 12 were custard creams.
Out of 16.
Out of 16.
So
that's good.
You can see. So we have 3 false positives, but we have this thing called accuracy, which is where we get, you know, where all the things that we've got right are there. So 21 out of 30. Right. So 70% odd, not bad.
Yeah.
Then we have you know, then we have these other two things, recall, and recall tells us that if we have true positives or false negatives, that's a value because that tells us something about a model, right, and we can improve it. And then we have this other thing called specificity. So this really underlies most of the things that we do with machine learning because we can have a feedback cycle with these. So Spark has all of this evolved in a framework called MLlib, which allows us to make predictions and then evaluate really nicely.
Even without using R? We're just down in the weeds at the moment. Okay,
that's right. Exactly. So it's baked into the Spark framework now. It's like part of the framework. And it allows us to distribute this problem, which is a very hard problem to distribute. You know, it's something that Microsoft has invested in heavily with our server, Azure ML, all of these different frameworks. So we get this for free with Spark.
Right.
So I'm going to show you one quick example, if I can, of this. And if we go back to here, what I will do is, in fact, let's go back to this. I'm going to shut this down just so that we don't take up too many resources because I haven't got a large Spark cluster here.
No.
But you know what? Let's mix this up a little bit, and we'll try a Python one.
Okay.
I ran this last night, so it was
we've got
quite late. I was a little bit groggy, so it might not work. But I'll just take you through this because if this does work, then it gives us a nice graph. So we're using a library called matplotlib.
Yes, I've used it before. Yeah.
And you know, and what this is allowing us to do is, let's give a Spark context here. Is you can see we create a Spark context, we'll read in this iris multi-class file, and then we'll split up this file. You can see that slightly different syntax for Python. We have to use this lambda operator, and this allows us to pass in an anonymous function. So in the same way as we are with Scala, everything from mappers to reducers, it's all anonymous functions. Okay,
right.
So very functional approach to this. Then you can see here that you can see this vectors.dense. So this is us creating a vector, like I was saying. Okay, so we're taking all of the attributes of that iris flower, the first 4 items, and we're putting those into a vector.
Yep.
Now, just to show you how easy this is, we have, as part of Sparks, part of the framework, we have principal component analysis.
Right.
So because I want to throw this onto a graph now, I have to take the number of dimensions down, because I'm assessing 4 features here, down to 2. Okay?
Right.
So that I can project this back onto the graph, so that I have an X and Y axis.
Yes, yeah.
I'm using a technique here called clustering. So I'm forgetting that I know what the flower is in this case. I just want to see whether I can differentiate some things.
Right. Yeah.
And
so we're doing a little talk on that on Friday with Woody, where he's going to talk about those kinds of things, about unsupervised, supervised learning, and what have you.
Yeah. Yeah, so it's basically that. It's unsupervised learning, and rather than using Python here, I'm using Python, and I'm using the interface with Spark. So Spark has all these libraries that are Python enabled in this case. So what I'm doing here is I'm creating a set of clusters, and I'm then using matplotlib to print out specific points on a graph. So that's doesn't look good, but I think that might be an old message. Let's run this. It might take a while to get our context, so we'll leave that running in the background, go back to slides, and hopefully we'll see a nice graph. Okay, because we've still got quite a bit to get through, and not a lot of time. So moving on, we'll take a brief look at Spark streaming. So the Event Hub is central to everything now in Azure, and it's especially central to Spark. We have this concept called a receiver, and we can partition many receivers, like physical nodes, which are streaming real-time data into Spark, and then we can just do queries on these in real time as if they were data frames.
Right. An alternative approach to stream analytics, would that be?
I think so, yes. And I think that in one sense they're very similar, because Stream Analytics has SACL, which is a query language. We can also use Spark SQL on the stream. So there's a similar approach there. But I think Spark has a much broader remit, because it allows us to run application code to interrogate those. So whereas with Stream Analytics we have the concept of functions, so we can offload something to a web service. I think there's a much more richer, cohesive model with
this
Spark.
feels, I think SACL might be more where we're doing on-the-fly tactical processing. Alan was talking earlier about Lambda architecture and so on. That's the immediate thing. We get a load of sensors coming in. We have a problem, Houston. Let's go and deal with that. Here we might be taking that real-time data and coming up with a more considered. It's going to maybe take a little longer, perhaps, if we're doing lots of decisions, because it's we've still got to compute some stuff, right? And therefore we're going to come up with a more considered thing about what's going on.
Yeah, and I mean I think SACL is more, I would say, is more streaming. You can adopt a streaming approach or a microbatch approach. In Spark you can only adopt a microbatch approach. So we have to have sliding windows of n seconds, for example. So Spark streaming, there's lots of different inputs and outputs. So we have these things called receivers, and that allows us to pull in data, and we can push data to a variety of things.
And here again we see that Kafka, not invented at Microsoft. Azure Storage, probably invented at Microsoft. Kinesis, not invented at Microsoft. Event Hub, invented at Microsoft. And so this blend of using the right tool.
That's right. So, I mean, looking at this as a traditional black box compute that can scale, and that's where Spark streaming really, really does well. So, we process data in microbatches. We can receive these streams on many nodes. So, in the case of Event Hub, we play to the strength, and the strength is that we can have many partitions in Event Hub. So we can receive many streams, and the benefit that we get is that we can join all of these in Spark. So streaming will give us one abstraction called a D stream, and then each D stream will have RDDs within it, that fundamental storage unit. So this is the idea of a D stream. We count the number of words, but you can see that we have that period of n seconds or n minutes, and we get a D stream abstraction for that. Then correspondingly, we can have a much larger window that we can inspect. And so we've got a lot of flexibility here. We've got two layers of flexibility. We have the primitive window, like each window dstream, or we can look at them accumulatively and say, well, actually, even though I'm collecting data every 5 seconds, I'm interested as well in having an event raised every minute telling me what the last minute of data is.
And we've got the longer term thing, rolling averages, and that, which could be building up over a much longer period.
Yeah, that's right.
Yeah, okay.
Okay, so
R server.
Lastly, we'll get to R server. R server, fantastic. So one of the things with R is that we can write our own modules. It's very, very extensible. Exactly the same with R server, but we can do this in a distributed environment. So so there's a large community of R programmers. So there's a natural movement away from, well, this works on my machine, to this now works in production.
Yeah, the traditional, I think, proprietary vendors there are really seeing this shift, and also obviously embracing those languages. But it's now like, I can take my algorithm and I can find it, I can share it, I can go to a community meetup, as we've been talking about, and that works really well. Everybody can get going. There's probably a module out there for you somewhere.
Yeah, absolutely. So, it's got a statistics background. There are thousands of algorithmic packages, and there are brilliant, as you said, ggplot too, so great graphical capabilities. So we can run R on multiple cores now. That's really important, right? We can run R on multiple computers. We've got efficient parallelization of these algorithms, which are notoriously difficult to parallelize and do in any kind of reasonable time. We've got support for the WASBA protocol, which we saw before, for storage, Hadoop's HDFS, Hive, SQL ODBC. All of these things are available to us at scale in R. So we've got these different components, Scale R, Connect R, Distributed R, which allow us to do the distribution, to do the scaling.
So just to be clear here, again for our audience, this is the Revo R acquisition bits and bobs that we've brought into the Microsoft world.
Exactly, yeah. And so effectively, our server is in Azure on HD Insight is now the platform service that encapsulates that. And where it couples with Spark is it uses the distribution mechanism that is available to Spark to get these things done.
Right.
So we'll have things like be able to download files to WASBA, and you can see in this case, this is a local temp directory. We've got a remote file URL. This is our HDFS directory that we download and copy to, and we use these RX commands to then copy.
These are the special, again, Revolution functions we got here. This RX kind of, so you can pick that out, because some of them are just the same names. I'm not here, but as the equivalent R function, but you're using the scale function.
That's right, exactly that. So we've got lots of different compute contexts, and in this case, we've got, whenever we start doing work on our server, we need to set the compute context. So we've got local, which is basically that single instance of R. We've got local PAR, which can use all of the resources of what is called an edge node, where our server sits on. And then we've got, after that, we've got a Spark context. So if we use this RX Spark, it allows us to do to utilize the underlying resources of Spark, which is fantastic. So we can do things like MapReduce and really scale out. So then we can also have a MapReduce context, which goes even further. So we can sit this on top of Hadoop or on top of Spark, but natively we've got access to both of these different contexts by the fact that Microsoft has released this as a platform service. So we don't have to do anything apart from issue this RX command. So we have a whole load of native functions, RX functions, that have been brought from Revolution, such as RX logit, logistic regression, decision trees, k-means, and these all happen at scale. We can evaluate things using sum of squares errors, and these are intense calculations on terabytes of data. So we can do these in realistic good time, and we can do classification and measure that through ROC curves. I am just going to check, lastly.
Just a quick, before we close off, Richard.
Before we close off,
Python do there?
We'll see how our Python did.
So to be clear then, we could have done this in R as well?
So we had a bit of an exception. What I might try, if we've just got a minute.
Go on then.
Brilliant, thank you. We're just going to take a quick look at the R server cluster, and I'm going to click on Secure Shell here. I'm going to copy this. We're now going to go back to our session, and I'm just going to paste that in. And I need to, what I'm going to do is set up a tunnel. So I've got RStudio server running on this on port 8787. So we're going to create a tunnel to this. I'll just enter my password.
Okay.
And there we go. Okay, so now when I go to my browser, I should be able to type in localhost 8787 and I should have an RStudio server. So it might take a little bit of time just to load the things up.
Right, so this is the other way you could develop. You could do it in Visual Studio. This is the traditional tool.
So I can cut and paste my R script. So you can see here that I've got some files for clustering and classifiers and things like this. It's doing a lot of work on the browser at the moment, so it takes roughly about 30 seconds to load everything. But for any R developers that are used to using RStudio, you can use this. It will tunnel straight into your cluster and you can do all of your R programming at scale.
Richard, that has been a lightning tour. I'd love to have kept you on here for longer. Thank you very much for coming in.
Pleasure, thanks for
inviting me. And we'll definitely be getting you back to show some more of this stuff.
Brilliant, I'll look forward to it.
Thank you for your time.
Thanks, Andrew.
Well, we'll be back after a 15-minute break, and we're going to be looking at sins in big data.